Welcome to section C in the 2018 paper. This is question C2, the structural forms question. So the graphic shows a footbridge near Liverpool which is based on a hyperbolic paraboloid. The projections of the bridge are given in C2 below. So we've got our projections here, elevation and plan. The elements of the hyperbolic paraboloid surface A, B, C, D, and A, B, C, D are extended outwards to form the curved outline loop of the supporting steel structure. Okay. Draw the given plan and elevation of the hyperbolic paraboloid ABCD using the number of elements shown and include the projections of a walkway. So part A, they want us to draw the ABCD, and to locate same with the elements and also the walkway. So looking at our question there, they have a scale 1:500. So just to convert that for you, 80 meters, okay? So 80 meters is equal to 8,000 centimeters, okay? Which is equal to, multiplied by 10, see how many millimeters in a centimeter, so 80,000 millimeters. Okay, and to convert that, we want to divide 80,000, okay, and that gives me 160. Okay, so that 80 meters, when we go to measure it on our drawing, is going to be 160 millimeters. Okay, and we can use that formula then to convert everything on our drawing. So you can see there I've now converted all of my measurements. So let's get on with the elevation. I want to come down a distance that's going to fit everything in. I've got 15, 64, so that's 80. I'll come down, I need more than that, so I'm going to come down a decent amount. Come down 160, there should be plenty of space on the sheet then. So my XY line. Okay, so A and C are 15 millimeters up. A and C are going to be there. Just say that's my A. B and D are 64 millimeters above that. 64 millimeters above. So at that height. Then the overall distance is 160, so 160 across. We'll find point C. And halfway across, so 80. So I'll draw that up vertically. That will find me point B and D. Draw my projections there. Just put a light line between it just in case I find points in between it. It also wants me to find the road, which is 16 meters, 32 millimeters. So the road is going to be at that level. And I'm just going to project down to locate A, B, C, D. That's A, sorry. Call that point D, and overall the distance between B and D is 90. Right, it's 45 meters, but 90 millimeters. So that's B, and halfway between that 45 to locate A and C. So I'll draw in my elements, or my parabola, hyperbolic paraboloid. Okay, and we haven't found our road yet, so let's continue on to finish that. And we need to find a straight line element so I can locate those points in the road, and I also need to find the element so I can find that distance out here. So the number of elements, we got 1, 2, 3, 4 divisions. So let's divide that up into 4 equal parts. Line at any angle, drawn up there, step off, set 4 times. 1, 2, 3, 4. 1, 2, 3, 4. Drawing my last points. Sliding set squares again back. And I've divided that line up into 4 equal parts. Okay, so that is going to be a point on my road, which I'll be using in a moment. And what I do now is to locate corresponding points up here. 1, 2, 3. Okay. So you can slide the set squares parallel to AD. I'm going to go here and I'll extend, draw my lines longer than they need to be for my elements. So they need them to be extended for later. Okay, and parallel to CD. To move this back a bit. Okay, so now let's locate these elements above in the elevation. Check it up. Okay. So my elements then, so this point 1, 1, this 1, 1. So let's join those together. If you want to index them, we can. 2, 2. So there's my 2 and 2, which are joined up already. 3, 3. Up to 3, 3. Those are in a straight line. elements drawn in there. And what's left to do is the projections of the row. Okay, so back here, I know that my rows is going to run through that point and that point, so I'll just draw lightly for now. Okay, so road running through there, but I don't know the end point for my plan. I need to come up here to my elevation. I've got that straight line element running through. I want to hit that point. Okay, so projections of the walkway. Okay, so I don't think we have to finish the walkway just yet. So I'm going to need to finish off, go on to the next section and come back to complete them, but I do have the projection of my road there and there. We just haven't got the heavy detail yet, or the finishing points of it yet. Okay, so part B then, draw the curve, or the curve ABC is a parabola, so ABC is a parabola, this is a parabola here. With vertex B, draw the elevation of this parabola. So let's draw the rectangle that's going to fit into. Do we have a height for that? $64. 64 divided by 4, 16. So you have two options here. You can use a construction to divide your line into equal parts, or you can measure up 16, 16, 16. Okay, and for the sake of speed, I'm going to measure up 16, 32, and another 16. Okay, and the distance out this way is 80, which I can also divide in 4. And I have done that, it's divided in 4 there. So just extend those vertical angles. I can join these now back. I've got a point, point, and point, and let's find them on the opposite side through axial symmetry. Which shouldn't be too hard. I could actually just extend up these vertical parts, just save us some time because they're all going to be divided up. So another point, and another point there. So let's draw that freehand curve AB and down to C. Okay, so our freehand curve there. Draw the curve. Back to our question. So ABC draws an elevation. We've done that. Project from elevation the given plan of the curved loop and project an end view. Draw the walkway in the end view. Okay, so let's start off with drawing the plan view of the curved loop. So on our elevation we have these elements. Okay, so we're going to extend those elements so that they find us points on our curve. Extend this element. And we've got that one. Okay, so we've got point. Okay, and our point there, there. We've got our straight line element. Across here. Okay, so let's project down onto that line 1, 1. Here's line 1, 1. Project down. I'll find a point. I'll find a corresponding point on this straight line element. And line 2, 2. Where is my line 2, 2? 2, 2. There it is. There's a point. There's a point, so let's project those down on that straight line element. Get that over on this side. Takes a bit of time to do these. There and there. Okay, so that is our curve found, our loop found. Okay, so that's my loop, and while I'm at it now, I'll come back and I'm going to finish off my, I don't have that line drawn yet, I do. Okay, I should have drawn my line C. Come back to it later. No, while I'm here, I might as well. It's a very easy thing to do. So line C is 12, which is 24 mil. That's E. Same this side, 24. That'll be none of that. I'm going to extend that on. So this is and then that straight line element that we found on the parabola cross onto line CE extended, that will find me the end of CE, same over here, and vertically up will find me the end of my road. So, that is my road. I can finish my road here. Plan. This symbol here just means it goes on to infinity, so I'll just draw my symbol there. Okay, so we're kind of getting there. Just to heavy in my CE, and another line over here. Okay, so projects elevation, curved loop, and project an end view. So we need to draw an end view now. So let's find A, B, C, D first of all. A, C, D, and B. My road is there. Got my road. Okay, and we want to find all these points up here. So find the corresponding points. We go 1, 2, 3, 4, 5, 6. That's a wrong point. That was a point for my parabola, isn't it? Yeah. So just highlight those points. 1, 2, and 3. Check it across. Okay, so let's join those up. Parabola shape. Okay, so quite a bit in that little bit. So let's see and draw the walking in. Done. The line CE is normal, is a normal to parabola. To the parabola at point C. So that's our normal. Determine the focal point and directrix of the parabola. Okay, so our focal point is going to be somewhere along here, and our directrix will be like that. So if I bisect the angle, so if I bisect this angle here, and that line coming back in, that will find my focal point. Okay, so that will be F. And the directrix then, because it's a because it's an ellipse, excuse me, third time around, because it's parabola, the ECC, eccentricity, is equal to 1, so the distance from your vertex, which is the point, say your focus, will be the same distance out to your directrix. So let's run through that. I'll do this, call that up, highlight it first. So compass, bisect, vertical lines, right? Vertical line, probably do it in orange. Bisect this angle. That will find in my focal. Okay, let's highlight that so you can see the orange. Okay, and as I said, the distance from my vertex to my focal point will be the same distance that I will have to my directrix. So just using another colour for that to show it. My directrix D. Okay, so that is everything we've asked. Just double check you've got heavy lines where they should be heavy, dashed lines where they should be dashed, and yeah, that is our solution to our structural forms question in 2018.